Welcome back to Advent of Code. Today we are working on day 16. The map is starting to be a bit more full here. And we have one of the longest program statement here. So I thought it's not really fun to read that on the stream. What's better is to actually make a little summary. We have some packets with packet header, 3 bits for the version, 3 bits for the type ID. There is one type ID that is known for now, which is 4. That's a literal value. When you have, then that's the format of the package, of the packet, sorry. And then everything that's not 4 is an operator. We don't really know what is an operator for now, but we know that there's another bit after the header. And depending if this is 0 or 1, you have 2 pieces of information here. So that's gonna be it, basically. So we're gonna take the template first, as always, you know. But we might do things a little bit different here. Because actually, let's check how the input is done. The input is just one line. So we're actually gonna take that here. And we just care about, so day 16, here with the trim, replace. We don't need to split a new line, we don't need to empty new line, just need that. And we even don't need the replace here. So we're gonna call that input. That's hexadecimal input, and here we're just gonna create one function for now. Function which is so we have several things that we want to do. First of all, I would like to have a function that is called parse packets. Input here, and what it does, we're just gonna write documentation first, actually. That's a first. So here, take a binary string, return a list of packets. Yes, that's one thing that I would like to do. And packet actually is going to be a class, because we want to do something nicely. I don't know actually how we do the constructor. I don't know exactly what we put in packet for now. Oh, actually we do know we need the version and the type ID. So version, type ID, and content. And we say, okay, this dot version equal version, this dot type ID equal type ID, and then this. And then we need to parse this content. Parse content. Okay, so there are so many things we need to do. And here, what I would like to have, no, I need another function. Because here we're actually going in the other way. Usually we just start by developing something little, and we just build on top of that. Here I just want the skeleton, the full skeleton, and then we dive into the implementation details. So here what I would like is something that is called solve. Or actually we could have part 1 that takes an input and that log, so takes an hexadecimal string, which is like this one here, returns a number. So here what I like is that we can say, actually, can we assert in JavaScript? I don't know, actually, to be honest, I don't know. Console.assert, what is doing console.assert? I'm just gonna check that briefly. Okay, I've just run console.assert 1 equal 1, 1 equal 2, assertion failed. So we're actually gonna use that for now. Console.assert, we want to do part 1 of, and here basically what we are doing is unit tests. That's so good. We can say this is equal to 16, And this, oh, we have so many inputs, which is 12, 23, 31. Okay, so we have our test case, which is really nice because we can just like build our stuff. And yeah, that's it. So const packets equal parse packets of input. Then we get a list of packets here. And what should we do? We need to sum the, so we're gonna say return packets dot and one thing that's not clear is that here we say it's version 4 contains an operator packet, version 1 contains an operator packet, version 5 which contains a literal value, version 6, so it's oh, it is 16. Okay, I get it now. Okay, so it's just the sum of versions. So here we can map and say p.version, and here we reduce ab, give us a plus b, starting with the value 0. That's, I've used that quite a lot, which is doing the sum of an array in JavaScript using the reduce function. So all the fun stuff is going to happen in parse packets, and we can start. How do we start actually? So here actually we need to translate this hexadecimal into a binary string. So that's one thing we're gonna say. Const binary, we're gonna start with that. So we do a parse int, and it's input, and it's in base 16, which is for hexadecimal, and then we have to do toString base 2. And here we have our binary input. We're actually gonna just console log input. Let's see what it does. Node, actually, we need to say node day16.js. Did I put a space here? What the hell? Day16.js. Okay, so map. Yeah, of course it is. We need to return here an empty array at least to return something. Assertion is failed, but we have our binary number, which should be. We don't have this input. We're actually going to use this input as well, which is this hexadecimal string. So here that's going to be battle tested, because yeah, I'm afraid we're going to have to reuse this code in the future. So making something clean is a good point. So yeah, I don't know about today, but maybe tomorrow we're going to need to reuse that. You never know. So yeah, it starts to be day 16, so it might be something that we reuse given the complexity of it. We need to say, wait, here we have just one value, which is 4, so it should be equal to 4 if I'm not mistaken. And here this string should be similar to this one. Yeah, like just looking at the start and the end, it is the same as this one. So yeah, we are good for the hexadecimal to binary conversion. So now the fun stuff begins. We have to say while input length is above 0, we need to do something with the inputs. So let remaining binary actually we can keep input here. You can keep input because this is when we change the string, it's gonna create a new string. So yeah, we are fine with that. We're not gonna override the string. So we need const version equal input that's, can you do slice? No, you need to do substring, I believe, in JavaScript. Start at 0, go to 3. So not including, yeah, so the 0, 1 and 2 should be in there. That's perfect. And then we have the version, we have the type ID, and here we start at 3 and we go up to 6, so 3, 4, 5, that's perfect. We have a type ID and 3 letters, and here we would like to actually pass that into binary, pass that from binary to decimal. Parse int, same, we pass from a binary number to a decimal number. That should be fine. We're actually going to be logging those two so that we are sure we are version type ID. Let's see. Up. Whoa. Here we're actually going to return an empty array just for now. Otherwise, this is an infinite loop, and that's not something we want. We have version 6, type ID 4, which is exactly what we are expecting. So we are great. So here, this is a packet that we are parsing. And now we need to say, okay, we have the version, we have the type ID. That's going to be interesting. So now actually let's go back to our nodes, and we have two options. We are going to start with the literal value because this is our first test case, so we want to make that right. And we say, okay, switch. Actually, let's use a switch because there might be several. For sure, there will be. Oh wait, is that the version? No, that's the type ID that we care about. Switch on the type ID. Depending on type ID, we have different behaviors. First behavior is case 4. I always write break because I don't want anything to happen. And here the default is all the other type IDs. That's the start. So we need the 5 bits. So here we're going to need to do some kind of a for loop. So first of all, we need to input. We need to actually do input substring starting at 6. And the idea is that we remove the version and the type ID from the initial string so that we have just the remaining data here. Here we say while input 0 is equal to 1. In that case, we say const. What do we have here? We need a literal value, so we need to say let binary string. It's empty for now. We're gonna say binary string plus equal input.substring, and here we start at 1 because we don't want to use this number, and we want 4 numbers, so that should be up to 5. So 1, 2, 3, 4. That's perfect. That's exactly what we care about. And here we can say input equal input.substring 5. And once we have a 0, what do we do with the rest? We don't care about the rest. So here we can just, actually we can return so here we say we don't care about the zeros afterwards. We can just break. One thing that we need to do is to parse actually this number. So we say let literal is equal to parse int binary string base 2, and so one thing that we're going to do is here we're going to say const packets is equal to an empty string, and here we just here we return packets. So here this is just temporary to avoid infinite loops. It's always good to write like this kind of comments, otherwise you just would have forgotten why there is this return here. So here we're going to say const packet, the current packet is equal new packet. Actually, for now, packet isn't going to even have a constructor, which is going to make that like an empty class. That's just going to be a bit dirty, but why not, Why not? Actually, you know what? New packet. Here, it's going to be version and type ID. Here, version and type ID. Okay, so we have our packets. And here we can say packet.literal equal this. What? Oh my. I think it's the linter who did something like magic here. I don't need the literal variable anymore. So here we need to make sure to do packets.push the current packet, and we should be good for the first case. Oh, we have no output anymore. So I think the problem with assert is that it's not displaying the information that we care about. 6/4. What? Why is it 6? Version 6. Okay, that's version 6. So the correct answer here is 6. Let's see. So here we have 1, 2, 3, 4. Something's fishy. I think the console assert doesn't look good. So I'm gonna cut the stream and cut the video and replace that. Okay, I've made it's a bit overkill, but I made like a little function that tells me whether the unit test passed or failed. So yeah, I think that's nice to have unit test for this because it looks a bit hairy. So that's gonna be for part 1. So we have this working correctly, which is the simple scenario. You have just one packet that is literal, that's it. Now we need to do this, we need to make this work for all of the type IDs. And let me look at my notes here. We have this information here that says, okay, what does it say? It says the first bit after the header, length, type ID. Oh, one thing I didn't take into account is that this is going to be like a nested packet situation. So this here is not going to be working, this reduce function. You know what? That's fine. That is fine. Here, what do we need to do? Let's just go step by step. First bit of the header, length, type ID. Const length type ID is equal input of 0. Then we're gonna directly remove this bit from the equation, from the string. Okay, that's it. Now we need, if this is 0, okay, so here we're just gonna say if this length type ID is equal to 0, otherwise, okay, that's gonna be our job. Here the next 15 bits, a number that represents the total length of bits. So here we know what we need to do. Maybe something like that. I'm going to say const number. Actually, that's what length in bits. Length. It's going to be a parse int. Here we go a bit faster. We do directly the parse int. We do input.substring from 0 to 15, and we should have the first 15 bits. Otherwise, here we need how many? We need 11 bits. Number of sub-packets containing sub-packets immediately contained by this packet. Okay, that's gonna be fun. So total sub-packets. That's gonna be fun. That's gonna be like a little bit crazy, I believe. Because we're gonna have a tree, basically a tree of packets, and that's something I didn't really think about so much, but that might get a bit complex. So number of sub-packets, yeah, that's correct. So the sub-packets appear after that. So one thing that I'm not super, oh wait, let's double check here that we made the right thing here. We said while input is equal to 1, we do that. But then I believe the next input should be equal to 0, and that's something that we haven't taken into account. So yeah, I don't have the right value in there. 2021. Let's actually check the value. Part 0. Should just check log console log packets. Haha. See, another mistake. Already a mistake. So literal, it's totally wrong. So here we need to say, here we know the next one, input 0 is 0. So we can just do that, which is binary string. We push the information and then we remove it from here. Now we have 2021. So see, this is like really, we really need to be super careful about everything. And then there can be zeros, but maybe not, maybe no zeros, maybe zeros. That's one thing that's a bit stressing, because here, basically, if so one thing that I'm thinking, if we do that here, let's not return packets here, and here we just want the first line. We're gonna do the unit test one by one. For now, we're focusing on the first one, and as you can see, we're creating a new packet, version 0, type ID, not a number. So that is not good. So here we can say if input is just a list of zeros from the beginning to the end of the string, then we break out of this for loop. Only zeros, most likely due to heading. Okay, so now we just have one packet, which is exactly what we should have had at the beginning. So that is perfect. We have what we care about. That is great. So we have managed to do that correctly for the first type of package. Now we're going to do the second type of package. That's going to be a bit more messy. To be honest, it doesn't feel like we need like complex algorithms today. It feels like more like we need to translate a complex piece of documentation into code. Let's do that. So total length in bits. So let's take this part of the sub packets contained by this packet. So here we know exactly we're going to need to do something like that. We're going to need to do const sub packets equal input.substring between 0 and length, and we need to do that. Then we need to remove this string. And what do we do with these sub packets? We are going to actually call recursively the parse packets on that parse packet sub packets, and here we're going to say packet.packets equal that. So actually we're gonna initialize, we're gonna say this dot packets equal an empty packet. So yeah, here we have the list, we have the content of the sub packets. Packets. Here we are parsing these packets, returning them as a list of packets that we are storing in the packets. So we have in the end a tree of packets. And we remove the data that we consumed from the input. That looks good, but now here, how are we gonna do that? Total sub packet is gonna be a bit more challenging. Hey. So here we're actually gonna say total sub packets equals -1. Let packets equal 0, and here we do packet plus. And here we're gonna say, and we need, oh wait, before I think too much about that, oh no, that's gonna be annoying. That this one is really gonna be annoying, because what I was thinking about, let's do something similar here. Instead of doing parse packets with a specific length, here we pass the full input and we pass the total sub packets here. But the problem is that we don't get how many. We don't know how many characters were consumed from the input here. So here we say, okay, if either total sub packet is below 0 or packet is below total sub packets. Yes. So basically here we can say, okay, parse the 3 next packets. And this can be done with this feature here. So here, if yeah, we don't say anything. Like here, it just doesn't care about the total subpackets, but here we actually send total subpackets, and that's to limit things. So so this, I believe we're gonna need to be careful about that, because maybe this is not right. So yeah, need to be careful about that. So here we lack one thing, which is how much has been consumed of the input string. Because when we send the input string here, it's just modified locally but never returned. So here we need somehow to know how much has been consumed. So here const or start input size equal input length, and every time we do a return, which is just here, we're gonna try to do something dirty, which is add a value to an array. Like we're gonna say packets dot consumed equal input dot length, no, start input size minus input dot length. That's a bit dirty, but I think that should work. And so here, basically, we're gonna use dot consumed as a way to say, okay, this has been consumed, remove that for the input, from the input. So that's something that we're gonna need to try. So first of all, we need to check we didn't mess anything for the default case. Okay, we messed anything. We already messed something up. Okay, so packets is defined here and here. That doesn't make sense. Total packets, of course. Here, total packets is below total subpackets. Here we need to say total packets. Okay, that's just I'm very like you might have seen already in a previous video. I'm defining twice the same variable. That's a mistake because it's a bit late at my place here. So we are good. Consumed, we don't really care about that, but hey, that's an information that's in there. Yeah, I think it should be fine. So now we can go and check the next scenario. So here, what's interesting is we have our first nested packet, and we see that this is not gonna work. Function sum versions packets. We're gonna say return packets. We're actually gonna take something almost like that. So this is here we say sum versions of packets. So that's exactly what we have right now. But what we need to do, we need also to sum the versions of p.packets. Meaning we need to do both to add the version with the version of all of the packets that are below it. And yeah, that should be good. Let's try that again. Oops, 10, 16. So that is not working. So we're gonna need to do some better display here. So we're gonna take our JSON stringify function that I really love. Oh, keep doing some weird shortcuts. JSON stringify function. I'm always typing that by heart. Maybe someday I'm gonna write a snippet for that so that I don't have to remember about it. So let's see. Here, this is where is this example? here we know this is the correct thing. Here, did we try this string? Is it this one? No. So we have another example. So we went too fast. We're gonna try every example to make sure we have like bulletproof code, because that might hurt a lot if we miss a tiny thing now. So here, what should be? It should be that. It's long. Another example. So here we need to wait for this example only. We have packet version. Let's actually just search for version so that we have like all the right information. Here version is 6 and here the version is just 1. Is that it? Literal value and literal value. So that should be 4, 4 and... Oh, I don't know. They don't say. Come on, why? So here it should be 1 plus here that's 4 plus 2, that's 6. So that should be 7 plus here that's 2, so 7, 9. So that should be 9 then, if I'm not mistaken. So we have 13. Let's look at what was passed. Version 7, version 2, version 4. If I'm reading correctly, the first. So here, packet, the sub-packet A. Maybe I should have like in the packet the binary representation of the packet. That would be really handy for debugging. That would be really cool for debugging, but I'm not sure I have like everything I need. Or you know what, let's not do that. So here we have packet of version 2 and type ID 1. So here already in the first sub packet we are wrong, because version 2 is not correct. Here version should be like 6, we said. So that is not correct. So maybe in the end we're actually gonna need to have like this thing. Wait, L is actually 20. Okay, no, my bad. So this is the length of the sub packet in bits, 27. A is first sub packet. Okay. Literal value representing the number 10. Okay. This is the first sub packet. Literal value representing the number 10. That doesn't look correct. Okay, so here we have like one packet that's too deeply nested. That is not right. So we need to make sure that's the kind of bug that it's good to catch it early. Let's focus on that. So we have a version that is 7. That's already not correct. I think I'm looking at the wrong string. Am I? Let's just look at this specific string, just to make sure we... Version 7. How is the version 7 when there is just 1 byte here? So that looks fishy. It looks like we might already have an issue at the hexadecimal to binary parsing. So we're gonna check that. Oh, I'm thinking maybe there's like some padding or something that I need to remove. Binary version is that 111. Okay, so here there are 2 zeros starting at the beginning. Why? that's typical bugs. Something that starts with a 0. Okay, I'm gonna need to read that again to find why. Here there are no. Why here they are starting with 2 zeros, 0, 0, 1, and here I don't have the starting ones. So could it be parsings and we put into binary? That's the thing. Most likely this is the conversion. Most likely I need to convert each number, so 3. Wait, that's most likely the conversion. Yes, here you see. Okay, so here in order to do the conversion we're gonna need to do something else. So in order to convert to binary we're gonna have to split our input. Then we'll need to map for each number n. We're gonna need to actually do the conversion into the conversion from base 16 to hexadecimal, and then we toString base 2, and then here we need to left pad left or left pad, I don't know. Pad starts with, so that the string is of length 4 and we pad with zeros. Now if we run that again, put that string in that function, yeah, not a problem. Oh yeah, here we have an array, we need to join that. That's just one string. And here we have our 2 starting zeros. Here we are. So yeah, I did a bad conversion. I should have followed that, and I wasn't following that. So of course you see some bugs, but thankfully they thought about these kind of bugs when designing the problem, and they give us some really nice examples that help us debug our code nicely. So now we actually solved it. Yay! Yay! So let's go to the next step. This is also working. Actually, let's remove this part. We're gonna actually uncomment everything. It looks like we've solved it. So now the only way to figure it out is to console log the part 1 of input, which is the input. It is this string at the top of the file that is read from this file. And so yeah, we're just gonna display that, and we have 1012. Let's look at that. And we are good. Let's go to part 2, and we have like a lot more text. So I'm gonna read that briefly. Really fun. So we are actually starting to build some kind of computer here, I feel, because we have like sum, product, minimum, maximum, greater than, less than, and equal to. So that looks like really some things that might be reused in future problem statements. I don't know, I don't know yet, but I have a strange feeling about that. So we need to make our code bulletproof for that. So 0, 1, 2, 3, 5, 6, 7. So here we just have to go here. So here, instead of a switch, because all of these other use cases are going to be using this code. So here I'm going to say if type ID equal 4, in that case we do this, otherwise we do that. and I can remove the switch case here. And we're actually gonna need a switch case, but it's gonna happen here after we have the list of sub packets. That's really what matters. Here we have the list of sub packets. We can act on it. So that's why we do the switch case at that point. Switch on, we need to switch again on the type ID. And it is from 0 to 7. Haha, it's gonna be a lot of stuff. So from 0, is it a number or I forgot if this number? No, I'm parsing it. So it's just 0, 1, 2, 3, 5, 6, 7. 1, 2, 3, 5, 6, 7. So here we're actually going to change. We have something called literal, and here we're just going to call that value. Do we have? No, we have nowhere else the word literal, so that's good. So here in case 0, we need the sum of the packets. So here we're going to say packet.value equal packets.map actually we just need to reduce a plus b 0, and here this is a.value b.value, and we start at 0, so that should be it. In case 1, this is the multiplication. So here, and we're, instead of reducing like that, we start with 1 and we multiply. That should give us the right. Let me make more space for the code. We don't really care about this input here. Okay. Okay, so that's the sum and the product. Then we need the minimum. Okay, that's just here. We need to say math.min, and here we in the packet we need to map them p.value. So basically we list the values and we take the minimum of those. I believe 3 is the maximum. Is that it? Maximum, yes. That is correct. Here, packet value, we need to do greater than. So 1 if the value of the first packet is greater than the value of the second. So packets of 0 dot value is more than and here we're just going to convert that into a number, because the idea is, why are we doing that? I'm going to show you briefly. Here if we do number of true, it's 1, and number of false is 0. So here we say if this is true, then we return 1, and if this is false, we return 0. So that's exactly what is said in the prime statement. This one, case 6, is the less than, so it should be the opposite, like that. And case 7 is equal 1 equal to the value of the second subpacket. Yeah, that's just like that. I'm just doing a equal because I don't know if I get some string or something. Let's actually do a triple equal, because it should always be a number. If value is not a number, then we have some trouble. Here we are parsing in, so this is, we know this is a number. Oh yeah, value should always be a number. If it's not a number, we are gonna run into some trouble. Okay, so I should add some comments, but let's not do that now. I think we are good. We are good in terms of implementation. Now we actually need to do the testing. So now, what do we need to do in part 2? So actually we're gonna have a function, function x to binary, because that's gonna be doing that. It's just gonna, I like to have some code that's relatively clean. So here we can remove that. So sum the version, that was the way to solve part 1. Now we need to solve part 2. I can comment those assert equal. Here we need to solve part 2 with an input. We still need to pass the packets, but here we don't need to do the sum versions. Here we need to do something else, and which is the outermost packet in your bits transmission. So it means that the packet at the top there's always one packet at the top. Hopefully that's the thing. So here we're gonna say just packets of 0.value. That should be part 2 in order to check if we are correct. Here we really want to catch any bugs, even if this is not a bug that's blocking us from solving this. We want to make sure the code is perfect, so that part 2 is gonna like the next days are gonna be fine. I'm gonna just copy that inside the code. Okay, so I'm done just writing, copy pasting each of these. So we have our test case scenarios here. We can run this, and we have some not a number. So that's good that we actually that's not good, but we're gonna make this work. So here we have the sum of 1 and 2. So here the sum. Okay, so one more thing, I need to add the comments here to understand like which each value is doing. I'm gonna add that. Okay, so type 4 is literal, and then I've added like all of these things. So now we actually want to here, console. I think wasn't there like a nice function to console dot? Yeah, I forgot. I think there was like a nice something else instead of doing JSON stringify all the time. I think there's something nice. Anyway, here we want to display the packet. Let's see what this does. We don't want all the test cases. We already failed the first one, so we're gonna be slow and do that right. That looks like there is some kind of mistake somewhere, because that looks like a huge thing totally wrong. Okay. So you're creating the packets failed. So C200, we need to actually do, damn, I should have like added this thing that adds a bit more debugging. Actually, can just debug here, binary. Actually here wait, that's part 1. That's dangerous. We need to not touch part 1. And here we don't want to pass the packets, and we don't want that for now. We just want, oh my god, this is not right. Oh, I think we are like touching part 1 here. Like we are displaying things from part 1. That's not good. I just want part 2. So I think there's a problem here. Wait, there's so many things happening. Why is this string so long? That makes no sense, right? This should be a tiny string. It should be, what's the length of this string? 10, so it should be a 40 character string. And instead this is like a huge, insanely huge string. So okay. Here we're using input, which is the input that's in my file, instead of using the input from the function. That's typical error. Okay, so still here there is a problem, but that looks a lot better. Parse packets. Oh wait, here if we uncomment that, it's still not a number. Okay, so we have version 6, which is 6. We don't care about 6, we care about the type ID that is 0. So it's a sum of the packets. The packets, type ID 4 and 4, it's 1 plus 2. So that should be, in the end, you do 1 plus 2, and that's correct. But here, not working, so I believe packet.value isn't saved somehow. How come? Packets should be the list. So here we have packet.value is not a number. So here we need to actually display packets. Oh, could it be this shitty thing that I've added here? I believe this is the problem. So here we're gonna need to do delete that. We're gonna need to do okay, so here we're using it, so here we do delete packets.consumed to clean things up, and we're gonna need to do that as well here, just to make sure this is super clean. And in part 1, let's do it again as well. Okay, that should clean things. Oh, we still have consumed here displayed. Become packets.consumed. Oh wait, that's not packets.consumed, that's packet. Okay. Packets.consumed. That's what we need to delete. So actually I can remove those two things. Yeah, so okay, so here I think we contain this weirdness. We still have not a number, while you should do 1 plus 2. What the hell? So here we're starting to see something weird. Reduce here. So we're gonna do, just gonna return. Maybe I'm learning something new here. Log A and oh yes, I know. Here, this is 0 here. That's not correct. So here I think it's just b.value. because A is basically the accumulator, so it starts with 0 and then it contains A plus value. Okay, so that was the problem. So here same, the first value is the accumulator, the second value is the new value that you're adding. So yeah, I believe that should be correct now. We solved it. Yeah, that was a little fear here. Let's see, next one. Okay, so let's see all of them at once. Everything is looking nice, which is feeling good. Let's remove just a little bit of, actually we don't care about removing too much console logs. Here I'm going to remove the test case from the output. And we have this big number. Let's run it. That was a long one, but not so much on the algorithm side, but more like on reading documentation and implementing a specification. Hope you found that interesting. Don't hesitate to drop a comment, a like, and subscribe if you haven't already, and see you in the next one. Bye bye.